A equals mc square in special theory of relativity is one of the most famous equations in physics. I will be explaining how to derive this equation. I will explain the meaning of this equation and then we will solve some problems. This is how we derive this equation. Consider a body of mass m which is moving with velocity v at time t. Suppose p is the momentum of the body and F is the net force acting on the body. Then by definition of force, F equals dp by dt. Consider the case when the body is moving in a straight line. Then on taking magnitude on both sides, we get F equals dp by dt, where F is the magnitude of force and p is the magnitude of momentum. Suppose delta E is the change in energy of the body from rest to gaining speed v. If the body is moving along x-axis, then delta E equals integral f dx, where f is dp by dt, so we get integral dp by dt dx. We can rewrite this as integral dx by dt dp. Since dx by dt is v speed, so we write delta E equals integral v dp. Call this equation 1. By definition of momentum, P equals gamma mv, where gamma equals 1 divided by square root of whole of 1 minus v square by c square. If you want to see how to derive momentum, see another video which I have posted on derivation of relativistic momentum. P is equal to gamma mv. We differentiate on both sides, we get dp equals d of gamma mv. Since m is a constant, so we write m into d of gamma v. By product rule, we get m multiplied by gamma dv plus v d gamma. Using the above in equation 1, we get delta E equals integral m multiplied by gamma v dv plus v square d gamma. Call this equation 2. I have written equation 2 here. Delta E equals integral m into whole of gamma v dv plus v square d gamma, where integral is taken from speed 0 to speed v. The expression for gamma is 1 divided by square root of whole of 1 minus v square by c square. We take square on both sides, we get gamma square equals 1 divided by whole of 1 minus v square by c square. Then we do cross multiplication, we get product of gamma square and 1 minus v square by c square equals 1. We differentiate both sides by using product rule of differentiation, and after that we simplify. Then we divide both sides by 2 gamma. After that we take d gamma on the left hand side and other terms on the right hand side. On the right hand side, 1 by c square we take as a common factor. Then we multiply both sides by c square. We get gamma v dv plus v square d gamma equals c square d gamma. Let us call this equation 3. I have written equations 2 and 3 here. Use equation 3 in equation 2. We get delta E equals integral mc square d gamma. The integral is with respect to gamma. The lower limit is 1 and the upper limit is gamma. Upper limit is gamma, which depends on v, and lower limit is 1 because when the speed is 0, then gamma is 1. Since mc square is a constant and integral d gamma from 1 to gamma is gamma minus 1, so we get the expression for delta E. Delta E equals product of mc square and gamma minus 1. We rearrange that and write this as product of gamma minus 1 and mc square. We expand and we get delta E equals gamma mc square minus mc square. We know that delta E is change in energy of the body when it moves from rest to speed v. So we can say that when the body is at rest, then its energy is mc square, and when the body is moving, then its energy is gamma mc square. And also we know that here delta E is change in energy of the body because of its motion, which means it is kinetic energy. We take kinetic energy as 0 when the body is at rest. So when the body is moving with speed v, then its kinetic energy is product of gamma minus 1 and mc square, when gamma depends on the speed v. Kinetic energy at low speed. We found that kinetic energy equals product of gamma minus 1 and mc square. Write the expression for gamma, which is 1 divided by square root of whole of 1 minus v square by c square. We can write the expression for gamma also as whole of 1 minus v square by c square raised to the power minus half. Then we expand that by using binomial expansion. Since we are considering the case when v is small compared to c, therefore in binomial expansion we can neglect higher order terms. After that we put 1 minus 1 equals 0. So we get kinetic energy equals half into v square by c square into mc square. Here c square and c square cancel. So we get kinetic energy equals half mv square. As you can see, this is same as the formula for kinetic energy in Newtonian mechanics. And this is as expected because Newtonian mechanics works quite well at speed which is small compared to the speed of light. So as expected, relativistic kinetic energy reduces to kinetic energy in Newtonian mechanics at low speeds. Let us derive the relation between energy and momentum. We found energy equals gamma mc square, and in a previous video as I derived momentum p equals gamma mv. From these two equations we get p equals ev by c square. Call this equation 1. We substitute the expression for gamma, then we get E equals mc square divided by square root of whole of 1 minus v square by c square. We take square on both sides, but then we do cross multiplication. After that we expand. So we get E square minus square of ev by c equals square of mc square. From equation 1 we find that ev by c square equals p. This means ev by c equals pc. We use that, then we get E square minus square of pc equals square of mc square. We rewrite this as E square equals square of mc square plus square of pc. As you can see, this shows that E, mc square and pc form a Pythagorean triplet where E is hypotenuse, mc square is one leg of a right angle triangle and pc is another leg of that triangle. We take square root on both sides. We find the expression for E and we simplify that as E equals square root of whole of m square c to the power 4 plus p square c square. So this is the relation between energy, momentum and rest energy of a body. Let us find the mass of a photon. The formula for total energy E is E equals mc square divided by square root of whole of 1 minus v square by c square. For a photon, speed v is equal to c. Therefore, the denominator in this formula approaches 0 for a photon, and still we want that the energy of a photon should be a finite quantity and not infinity. That is possible only if m is 0. This means a photon is massless. For a photon, mc square equals 0 into c square, which equals 0. Therefore, the total energy of a photon is, because of its kinetic energy, total energy equals kinetic energy for a photon. There is no frame of reference in which a photon is at rest, which means there is no frame of reference in which the kinetic energy of a photon is 0. Note that it is invalid to fix a frame of reference on a photon itself. We found that in the formula for E which I have written here, both numerator and denominator are 0. So we get 0 by 0, which is indeterminate form. From indeterminate form, we cannot find the value of energy of a photon. Then how do we find the value? For that, we use quantum physics. From quantum physics, energy of a photon equals hf, where h is Planck's constant and f is the frequency of the photon. Let us discuss the meaning of E equals mc square. Mc square is the energy of a body at rest. If the body is moving, we also need to add kinetic energy. The meaning of E equals mc square is mass is a form of energy. Mass m is equivalent to energy mc square. We know that mass is a measure of inertia. Inertia is the property of a body by which it resists changes in its state of motion when an external force is applied on it. This means that the mass or inertia of a body depends on its internal energy content, where energy E is equivalent to mass E divided by c square. Internal energy of a system is its total energy in a frame of reference which is fixed on the center of mass of the system. We know that one form of energy can be converted into another form of energy. As we discussed, mass is a form of energy. So mass can be converted into other forms of energy. Similarly, other forms of energy can be converted into mass. A body's mass increases when it is heated because heat energy is also equivalent to mass. The mass of a spring plus block system increases when the spring is compressed or extended from its natural length because of stored electrostatic potential energy, which is equivalent to mass. A rotating ceiling fan has more mass than the same ceiling fan when it is at rest because of rotational kinetic energy. The mass of Earth plus a block system increases when the block is lifted higher because of increase in gravitational potential energy. Note that in this case, the mass of the block alone does not increase because the gravitational potential energy does not belong to the block alone. It belongs to Earth plus the block system. So the mass of the Earth plus the block system increases when the block is lifted higher. The rotational kinetic energy of Earth due to its rotation about its axis contributes to the Earth's mass. This is because if we fix the frame of reference on the Earth's center, then in this frame the Earth has rotational kinetic energy which is equivalent to mass. The translational kinetic energy of the Earth due to its orbit around the Sun does not contribute to the Earth's mass because the Earth is not moving from one place to another in a frame of reference which is fixed on the center of the mass of the Earth itself. If we consider the Sun plus the Earth as a single system, then the mass of this system is not simply equal to the Sun's mass plus the Earth's mass. We also need to add the mass equivalent of their gravitational potential energy and also the kinetic energy of the system relative to a frame of reference which is fixed on the system center of mass. Note that the Earth does not move from one place to another with respect to its own center of mass, but it moves with respect to the center of mass of the Sun plus Earth system. Let us solve some problems. Problem number 1. A mass of 1 microgram is equivalent to how much energy? Pause the video, try to solve the problem yourself and then proceed. Mass m is 1 microgram, that is 1 into 10 to the power minus 6 gram or 1 into 10 to the power minus 9 kilogram. We use the formula E equals mc square. We put the values of m and c, calculate, then we get E equals 9 into 10 to the power 7 joule. So a mass of 1 microgram is equivalent to an energy of 9 into 10 to the power 7 joule. Problem 2. Calculate the binding energy of 6C12 nucleus. Mass of the nucleus is 12 unit. Mass of a proton is 1.007825 unit and mass of a neutron is 1.008665 unit. 1 unit is equivalent to 931.5 mega electron volt. Pause the video, try to solve yourself and then proceed. The mass of a carbon-12 nucleus is 12 unit. The nucleus has 6 protons and 6 neutrons. So the total mass of these protons and neutrons is 6 into 1.007825, which is the mass of a proton, plus 6 into 1.008665, which is the mass of a neutron. This gives us 12.09894 unit. So the mass defect is delta M equals 12.09894 minus 12. We get 0.09894 unit. Here mass defect means the mass of protons and neutrons in the nucleus minus the mass of the nucleus itself. This mass defect is equivalent to binding energy of 0.09894 into 931.5 mega electron volt, because 1 unit mass is equivalent to energy of 931.5 mega electron volt. So we get binding energy of 92.16 mega electron volt. Problem 3. Two bodies, each of mass m, are moving at speed 0.6 c towards each other. They collide and stick together. What is the mass of the final combined body? Pause the video, try to solve the problem by yourself and then proceed. Consider the two bodies as our system. The momentum of the system before collision is 0. This is because both bodies have the same mass and their velocities are equal in magnitude but opposite in direction. So by conservation of momentum, the momentum of the final combined body also will be 0, which means the combined body is at rest. Total energy of the system before collision is 2 into mc square divided by square root of whole of 1 minus 0.6 square. From the formula of total energy, we get total energy of the system before collision equals 2.5 mc square. Suppose capital M is the mass of the final combined body. Since the combined body is at rest, so its total energy will be capital MC square. By conservation of energy, we get capital MC square equals 2.5 small mc square, or capital M equals 2.5 small m. So as you can see, the mass of the combined body is not simply equal to the sum of the two bodies. It is not simply 2m. Here we are getting mass equals 2.5 small m. Problem number 4. Two bodies A and B, each of mass m, are moving at speed 0.5 c each towards each other. They collide and stick together. In the frame of reference of A, calculate part A, the velocity of the combined body, part B, the momentum of the combined body, and part C, the mass of the combined body. Take the direction of motion of A as positive. Pause the video, try to solve part A of the problem yourself and then proceed. Here is the solution to part A in the observer's frame, where observer means the observer in whose frame the scenario is given. We get the total momentum before collision is 0. This is because before collision both bodies have the same mass and they are moving with velocities of equal magnitude and opposite direction. So by conservation of momentum, the momentum of the final combined body also will be 0. So the velocity of the final combined body is 0. And the velocity of A is 0.5 c. So in the frame of reference of A, the velocity of the combined body will be 0 minus 0.5 c, which means minus 0.5 c. Pause the video, try to solve part B yourself and then proceed. Here is the solution to part B. In the frame of reference of A, velocity of A before collision is 0 because we fix the frame on A itself. Using velocity addition formula, we calculate the velocity of B before collision in this frame, that is frame of A. We find velocity of B before collision is minus 0.8 c. It has minus sign because the direction of motion of A is positive and B is moving in opposite direction. So the total momentum before collision is momentum of A plus momentum of B. Momentum of A is 0. Momentum of B is calculated using the formula gamma into mass into velocity, where gamma depends on the speed of 0.8 c, mass is m, and velocity of minus 0.8 c. So total momentum before collision is minus 4 by 3 mc. By the law of conservation of momentum, the momentum of the combined body after collision is also minus 4 by 3 mc. Pause the video, try to solve part C yourself and then proceed. Here is the solution to part C. In the frame of reference of A, the velocity of the combined body is minus 0.5 c. We calculated that in part A. So we find gamma for the combined body. We find the value of gamma as 2 divided by root 3. Suppose capital M is the mass of the combined body after a collision. The momentum of the combined body therefore is gamma into mass into velocity, where gamma is 2 divided by root 3, mass is capital M, and the velocity is minus 0.5 c. And we already calculated in part B that the momentum of the combined body is minus 4 by 3 small m into c. So these two will be equal. We simplify further and then we find that capital M equals 4 root 3 by 3 small m. So this is the mass of the combined body. As you can see, this is greater than 2 times small m. Problem 5. Two bodies A and B, each of mass m, are moving at a speed of 0.5 c each towards each other. They collide and stick together. Calculate part A, total energy of the system before collision, and part B, mass of the combined body after collision. Pause the video, try to solve both parts A and B, and then proceed. In part A, both A and B are moving at same speed before collision, so they will have same gamma. Total energy before collision is energy of A plus energy of B, so gamma mc square plus gamma mc square or 2 gamma mc square. The value of gamma is 1 divided by square root of whole of 1 minus 0.5 square, because speed of each body is 0.5 c. Gamma equals 2 by root 3. So total energy before collision is 2 into 2 by root 3 into mc square. This equals 4 by root 3 mc square or 4 root 3 by 3 mc square. In part B, by law of conservation of energy, total energy after collision will be equal to 4 root 3 by 3 mc square. Suppose mass of the combined body is capital M. By law of conservation of momentum, the final body will be at rest, as we saw in problem 4. Total energy after collision therefore will be capital MC square. Now these will be equal capital MC square equals 403 by 3 small MC square. From this we get mass of the combined body as 403 by 3 small m. As you can see, this is the same answer that we got in problem 4 part C. In problem 4 we calculated mass of combined body using law of conservation of momentum. Here we have used law of conservation of energy, and as expected both ways we get the same answer. Problem 6. There are two bodies A and B, each of mass m. Body A moving at speed of 0.6 c collides with B, which is at rest. They collide and stick together. Calculate the mass of the combined body after collision. Pause the video, try to solve the problem yourself and then proceed. This is how we solve. The speed of body A is 0.6 c. From this we find the gamma for body A. We find gamma equals 1 by 0.8. This equals 5 by 4. Total momentum before collision is momentum of A plus momentum of B. Momentum of A is gamma into m into 0.6 c or 5 by 4 into m into 0.6 c. Momentum of B is 0. So we find total momentum as 3 by 4 into m into c. Total energy before collision is energy of A plus energy of B. Energy of A is gamma mc square. Energy of B is mc square because B is at rest. So total energy is 5 by 4 mc square plus mc square. This equals 9 by 4 mc square. By conservation of momentum and conservation of energy, the final combined body has the same momentum and the same energy as initial total momentum and total energy. So the combined body has momentum P equals 3 by 4 m into c and energy E equals 9 by 4 mc square. Then we use the formula E square equals square of Pc plus square of capital MC square, where capital M is the mass of the combined body. We put the values of E and P. Then you can try solving the equation yourself. You will find that capital M square equals 9 by 2 into a small m square, or capital M equals 3 root 2 by 2 small m. So the mass of the combined body is 3 root 2 by 2 small m. As you can see, this is a slightly greater than 2m. Hope you found the video useful. Please like and subscribe.